I'll get those. Okay, so why don't we get started now? I just want to say hello to everybody and thank you so much for joining us for today's program. My name is Melissa Loriano and I serve as the Programs Associate for the DC Preservation League. Before we officially get started, I just want to share a few brief technical notes with you all about how today's program is going to work. So please use the Q&A chat to ask any questions of our presenter. I will collect your questions and verbally ask them to Adam at the end of the program. We'll have time allotted for Q&A. And if we do not get to everybody's question, I will make a note of the ones still in the chat and pass them along to Adam. And if you think of anything afterwards, you're more than welcome to email us at info@dcpreservation.org, and we will pass those along. For those of us joining on Facebook Live, my colleague Jessica Unger, our Outreach and Grants Manager, she will be monitoring any questions you might have and will pass them along to me as we get to the Q&A portion of today's program. So I'm so pleased to introduce you all to today's speaker. Adam Rush is a senior consulting engineer with the engineering firm Simpson Gumpertz Heger, who are a DCPL Business Member, and we thank you for your support. He has extensive structural engineering experience managing condition assessment, renovation, adaptive reuse, and historic preservation projects involving vital structures at risk of flood damage. He is an active member in the Association for Preservation Technology and served as the president of the organization's Washington, D.C. chapter in 2013. And with that, I will turn things over to Adam.
All right. Well, thank you, Melissa, for that introduction. Again, thank you for inviting me to give this presentation today. I think it's a very engaging topic, and I look forward to all the questions at the end of this presentation. And I am very excited to be here and to talk about what happened at Ellicott City and what can we learn as a community to move forward. So, kicking off, I'd like to talk about the outline real quick to try to give a sense of what we're going to cover today. So we're going to start off with the background for Ellicott City. We're going to talk about the history of the town a little bit. We're going to talk about the recent floods that occurred there. And we're going to talk about what are the goals and what are they doing to move forward as part of their recovery effort. And from that, we're going to focus on one specific building to help tell that story, and that is Caplan's department store, as you can see in this photo here. The location of this structure is at a critical juncture within the city, and there's a lot that is going on with this building and the preservation effort behind it that really tie into the larger flood concerns and larger preservation concerns for Ellicott City. Now, we're going to use Caplan's to talk about a conceptual flood mitigation study that would occur using code prescribed methods and procedures in order to understand how to think about flood mitigation for historic structures. Then we're going to take what we learned from that conceptual study, we're going to bring in the recent history and the efforts going on throughout the city, wrap it up to talk about how that ties into the project moving forward with Caplan's, and open it up for questions at the end of the presentation. Ellicott City, Maryland recently was devastated by 2 flood events. Now, these flood events were triggered by rain events that were 1,000-year return period events, and we'll talk a little bit more about what a 1,000-year event means later on in the presentation. Needless to say, they were hit with heavy rain events that caused significant flooding and flash flooding downtown. Now, Caplan's department store was constructed around 1910, and it is a contributing element to the historic district, and that is the main driver of the preservation that is going on with Caplan's, is how it interacts with the streetscape and the historic downtown nature. So Ellicott City sits along the banks of the Patapsco River in Howard County, Maryland, about half an hour or so west of Baltimore. The Patapsco River runs from the north to the south, and Main Street crosses the Patapsco River near the south end of Main Street. I'm going to put on a highlighter to try to point things out, and hopefully this works. We'll see how that goes as we move along. So Caplan's department store is located at this corner on Main Street, where Main Street turns in a bend. So the location for Ellicott City was chosen for a mill town because of the confluence of a number of tributaries to the Patapsco River, creating a constant source of water in order to power the mills. And so they constructed Main Street along this channel where the Tiber branch meets the Hudson branch and Newcut branch and runs parallel to Main Street. Now this city has a history of flooding, and traditionally floods would come from heavy rain events up in the watershed of the Patapsco River and would cause the river to increase in elevation and have the waters back up Main Street. So you end up getting high water levels, but the flow of the water is relatively slow within the downtown area. However, so due to development within the watershed of these creeks or these streams, we found that the nature of the flooding has changed for Ellicott City. Where before floods were occurring from the Patapsco River at the end of Main Street, slowly moving up Main Street as the water levels rose, they're now coming from the west and the north, where the watershed collects water and then quickly funnels it down through this channel in lower Main Street. And as a result, the water accumulation occurs much faster, and the level of flooding can increase in elevation pretty quickly, and the water movement is also very rapid. Now, to set this into a broader context, let's look at what NOAA is tracking for billion-dollar weather events caused for the last couple of years in climate disasters. So NOAA has tracked damage from tornadoes, flooding, earthquakes, droughts, etc., and have tabulated the events for the past number of years. And as we can see on the table on the right, flood costs, though not occurring every year, can quickly accumulate, where one flood event could easily cause over $1 billion of damage. And this does not even account for all of the floods that occur that don't reach the $1 billion threshold. So flooding is a major source of disaster, and it is a major issue that we need to confront moving forward. One of the challenges that we're going to face as a community is that projected change in total annual precipitation is also going to change due to climate change. So areas of the United States, we're projected to see an increase in rainfall in the future. And so each event where we have the heaviest 1% event happening per year, that occurrence is going to increase due to changes in climate change. As you can see, where we live in the DC region, where we live in the DC metro area, here on the Potomac River, we're looking at, on the low end, a 20%, give or take, increase in heaviest rain events by late 21st century. So in the end, in the next 100 years, we're going to see a 20% increase, and then up to 40 to 50% at the high end of the range. So we're going to be dealing with a lot more water for our historic sites, and we need to take that into account as we move forward with our designs. So with that in mind, I want to go through a flood mitigation study using a code method in order to set the groundwork for what it is that we were going to look for. So within this study, we're going to look at the framework, like how do we put together this problem? How do we think about flood mitigation for historic structures? We're going to talk about that framework, and we're going to go into what are the flood risks, how do we deal with those risks, and then look at different mitigation strategies, and then come up with a potential recommendation for a project moving forward based on the data that's available. So this is all based on what is published and the codes that apply to Ellicott City. And we're going to use, again, Caplan's as our example to talk about this. So first, design framework. So thinking through this, we thought it would be helpful to lay out a procedure recommended, almost like a flow chart, to think through how you would tackle a flood mitigation project. So first, we would identify and communicate with the relevant stakeholders. Obviously, it's the building owner, then it's the design team, then you have the building code official, you have historic preservation review boards, and then other community organizations that also get involved. And it's important to identify all of the relevant stakeholders early on the project so that they can be involved with the entire project as you move forward. Because with flood mitigation, there's going to be a lot of give and take and a lot of discussions that's going to require input and acceptance from many different levels. One level to consider is insurance. So for larger projects where the building is not covered by the federal flood insurance, many private insurers are requiring more stringent design methods and insurances for their buildings that they are going to insure against flood damage. They're not just saying, okay, you can meet these minimum standards that's set by the code and we're going to give you a policy. They're saying you actually have to go above and beyond that. And that's why it's important to get all of the stakeholders involved early on in a project. Step two, you got to define your performance goals. What do you want to see for this building? How do you want it to function? Do you want it immediate occupancy after a flood? Or do you want to allow some damage to occur and a rapid recovery? What are the levels that the flood elevations that you want to set based on maps? And then what do you want to get out of this project? And part of that is going to be historic preservation. What are the key aspects that you have to preserve in order to stay on the historic register? Next is identifying the flood hazard, evaluate what the risks are and the criteria that you need to design for. You have to identify historic features and then vulnerabilities of your structure. And a lot of that is going to be based on the nature of your building. Is it a wood structure, masonry? And it's also going to be dependent on the nature of the flooding and how everything kind of interacts. And then we come over to this fifth step, which really is going to be a bunch of steps that you have to keep checking and rechecking as you reevaluate your decisions. So you're going to determine what flood mitigation strategies that you're going to consider. You're going to evaluate the flood resilience implications and how effective they are, develop feasible, and you're going to try to balance flood mitigation and historic preservation and look at thresholds, essentially where you can't remove certain pieces of your historic structure because you would lose your historic designation. You could remove certain pieces and put them back. You know, this is where, again, you have to make sure that you're constantly communicating with all the relevant stakeholders. And then every project and the goals and outcomes and actual execution are going to be based on cost. And part of flood mitigation for these historic structures is not just project costs specifically, but it's going to end up being a life cycle cost that you're going to have to, or you should consider, because we want these buildings to remain in place for a long time, and we need to understand what sort of maintenance program is needed in order to continue to protect your building. It's not something that you simply install. You know, it's not a new beam that you install. A lot of these mitigation methods require maintenance over the course of a year in practice and deployment. And like I said before, this is an iterative process. You have to constantly go back and reevaluate as you learn more. Finally, you make an informed an informed decision based on the risk, and you move forward and try to enhance the resilience of your structure. So, for Caplan's, with a conceptual study, we start with the stakeholders, which would include the owners of this building, which are not the last name Caplan's. It's a private firm. Let's say they want to renovate it for retail, and they are working with the historic board in order to go through their plans and make sure that they keep the historic features that contribute to the district. So we're identifying all the stakeholders at the start of this conceptual flood study. And then performance goals, you know, based on the nature of Ellicott City, up until recently, it has flooded periodically. Floods have been, there has been serious damage from flooding quickly and receded quickly. And so I apologize, I just got a note that my internet is unstable. Hopefully we don't get too choppy of a presentation here. I apologize if we do. But we define the goals. Let's say the owner wants to immediate occupancy. That means they have a very stringent design in order to keep waters out and keep the damage low, so that as floods come and go, they can keep the building open once the waters are gone. So next, and this is really the fun part, we get to characterize the flood hazard. So let's talk about floods. First, let's start with types of flooding. Most people are familiar with coastal flooding, which would come with hurricanes and other storm surges. These flood events tend to have significant wave action associated with them, and we are anticipating increased coastal flooding risks due to climate change and sea level rise. And there are many historic communities that are looking at what these projections are for the future and trying to determine how do we address them moving forward. Another type of flood risk is riverine flooding. And this is very common around our area with the Potomac River, Anacostia, and in this case, the Patapsco River. Riverine flooding can come from large rain events up within the watershed that may not even cause any rain at the location of the flood. So for instance, DC may get flooded because a tropical storm sets up in the Shenandoah Valley and just hangs out there for a while. And DC may not have any rain, but a large flood may come through regardless. Another potential flooding characteristic of riverine floods are rapid floods from rain events or flash floods, where water accumulates quickly, and where it gets funneled through the watershed, where it gets funneled through the flood channel, you can get really high water velocity in those areas, and that is extremely dangerous and extremely destructive. So there's a lot of design requirements and a lot of regulatory hurdles that you must be aware of and go through if you're going to be within a flood path, or a now the term is escaping me, unfortunately, within the course of a flood. Then there's local flooding, and this can occur from heavy rain events where water can accumulate quickly. However, it's not really centered around a river per se. It's more of a storm water management problem, where the water volume and rate is too high for that stormwater management to accommodate, and water can accumulate and cause local floods. And that can also cause local failures, particularly at culverts, etc. And it is something that is not currently covered with FEMA maps, but there are plenty of local jurisdictions that are working with ArcGIS programs in order to model rainfall events and look at spots where, at a particular low spot, you could get local flooding. And so anytime you're dealing with a project where you look at the topography and it looks like you're at a bottom of a hill and it looks like a lot of water could accumulate to your site quickly, chances are there are resources within the local jurisdiction to evaluate those areas. And that's something that one of our teams in Simpson Gumpertz works on as well. So we talked about all the different types of flooding, and for the rest of the presentation, we're just going to focus on riverine flooding, because that is the type of flood we had at Ellicott City, and the rest of the challenges associated with flooding are going to be surrounding riverine flooding. So let's look at flood hazards and how do you legally define a flood hazard. And currently we use FEMA firm maps. So it's flood insurance rate maps, where using different hydraulic and hydraulical studies, I always mess up those words, I apologize, we set the elevations for floods. And from these maps, we determine what the hazards are for a particular project. So let's zoom in on a part of Washington, D.C. that I think is illustrative for how to read a map and what to look for. So to set the orientation, we have the Capitol building to the east, or on the right of the screen. We have the Lincoln Memorial to the left. We have the Washington Monument in the center. So we're obviously looking at the mall. And then down at the bottom, we have this poor Jefferson Memorial surrounded by blue. And what that blue represents is a 1% annual chance of flood, also known as a 100-year flood event. And so what does that mean in terms of actual return period, likelihood of occurring, etc.? So let's say you have a project where you expect it to be around for, say, 30 years. And you say, okay, I am going to design for the 100-year flood. That means there's a 1% chance of a flood occurring every year that the building is there. And over the lifetime of the building, that adds up to about a 26% likelihood that your structure would see that flood. What does that mean for buildings where we want these buildings to stay forever? that's worth thinking about moving forward. I don't have a good answer for that right now, but it is something worth discussing at the end of the presentation and afterwards. So, Ellicott City. We go to the flood hazard map from FEMA, and we learn that for Caplan's department store, it is within the 1% chance of annual flood. It's in a 100-year flood zone. That makes sense, given our understanding of the city and topography. Main Street elevation at the entrance to Ellicott City, Caplan's is right around, we'll say, 131 foot. Base flood elevation from these maps is at 133 foot. And now we need to decide, okay, what do we want in terms of what's called freeboard? And that is the level of safety that we want to add to the project. So the base flood elevation comes from modeling of the topography and rain events and looking at how water will work its way through the system and what the results are. There is definitely some conservative and some factors that go into developing those elevations. However, the code also says you should take those elevations and based on use of your structure, you should add either a foot or 2 feet or just take the elevation as it is. And that's what you design for. So if it's a low risk, you would just design for that flood elevation. If it's a high risk structure where if it were to be damaged, it would cause a lot of problems, you design for a higher elevation for flooding in order to provide more of a guarantee that your building will resist future flood events. All right. And now we come back to the flood mitigation framework and we say, okay, we have our structure. What are the historic features? What does it look like? And so far, I've only shown you the facade as viewed from Main Street. And that's because that's the historic portion of this building. It contributes to historic downtown, and it's actually included in the Secretary of Interior standards for historic properties for, let's see here, treatment of, I used to know this one, for treatment of storefronts. There we go. Okay, well, let's talk about the rest of the building and get a sense of what it is that we're dealing with, because that is very important in how we analyze the flood hazards and how we try to address the flood hazards for our structure. So this is a floor plan looking north. Along Main Street, we have our entrance. And then we have the first floor right off of Main Street. It actually slopes up, believe it or not. And then the interesting thing about this structure is that it actually extends over the Tiber branch. So at some point during the history of Ellicott City, building owners started to construct their structures over the Tiber branch in order to increase their square footage. Now, some of the mills may have done this originally in order to have their water wheels in the Tiber branch to generate the power for their mills, but the retail spaces also copied that procedure. And what we see when we look at what this, now let's look at how this building looks in section and kind of get a sense of what we're talking about when we say we extend over the Tiber branch. So Caplan's in section, we have our storefront at Main Street, come into the first floor, and it does have a basement. And it also has a second floor with roof access. And then above the first floor, it extends over the Tiber branch. And this looks like, from below, we see steel framing supported by flood walls with various states of repair and periods of construction. The flood walls, portions of them are concrete, other portions stone, and there are even some locations where brick is corbelling out in order to pick up existing party walls. And so this is what we see from below the structure. So what does that mean in terms of the flood? You know, what kind of risk do we have to address for our flood design? So as a reminder, we have the base flood elevation about 2 feet above the first floor, and then the owner would like to be able to open immediately. And so based on the code, we say, okay, that's another 2 foot of freeboard that we need to accommodate. And so when we look at the floodwaters, we see that, you know, we have water rising at the front and within the Tiber branch. And so there are 2 sources of damage to consider for flooding. One is water infiltration and damage to your finishes and damage to your structures through water damage. And this building is susceptible to water infiltration through the front storefront, through the storefront doors, and also through the basement walls, water moving up through the floor and then coming from the end wall as well. The other aspect you have to consider is hydrostatic pressure on your structure, and that is the lateral pressure of water from the weight of the water on your building features. And then in this case, we have uplift pressure on an elevated structure because the water level for flooding is actually above the first floor framing elevation. And so let's go into different mitigation strategies and talk about how appropriate they are for our condition and whether they're appropriate. So at an individual building site or equipment, we tend to resist the demand from flooding, and that is usually how we mitigate the flood risk to our structure. We can't really reduce the amount of flooding upstream. We can only address the results once it gets to our building. So the first options of relocation and elevation are historically and obviously the best way to avoid flood damage to get out of the way. Of course, we'll look into those in more detail. Then there are different types of flood barriers that are available on the market to discuss and when those are appropriate, when those aren't. And then there is wet floodproofing and dry floodproofing. And all of these options have to be considered for each individual site in order to address the flood resistance. As I just said, relocation and elevation are historically acceptable and, well, historically used in order to avoid damage from future flooding. However, at Caplan's, we obviously can't move the building off of Main Street because that's the whole character contribution to the historic city center. We discussed briefly maybe raising the elevation of the first floor. However, that's not really achievable with how it interacts with the streetscape. And so obviously elevation, relocation are not options. So we can talk about flood barriers. So first, flood barriers come in many different shapes, sizes, and concepts. You can have temporary flood barriers or temporary flood gates like the Washington Harbor in Georgetown on the Georgetown waterfront, where if they receive a warning from upstream at the Potomac, the building management comes up and raises these floodgates in order to keep the water out from this sunken patio area. However, if they don't get the gates up in time, there has been occasion where there has been flood damage from past events. So flood gates and flood barriers typically are temporary systems that have to be raised and lowered in the events of flooding. Sometimes they can be automatic and are weighted with buoyancy weights that would just automatically push open the gates so that you would seal off your building or your structure. But many of them have to be deployed prior to a flood. And so there are plenty of instances where you have to consider all the ramifications of that. Now for Caplans, we don't really have the option of deploying floodgates to keep the water away from our building because our building is tied into adjacent structures and the floodwaters really need to go underneath our building already. So obviously this is not an option for Caplans. That leads us to wet floodproofing and dry floodproofing. So with wet floodproofing, we let the water in, that hence the term wet, and we balance the hydrostatic pressures as a result. With dry floodproofing, you keep the interior substantially dry, and you have to resist the flood pressures as a result. So looking at the two in comparison, I find helpful and thinking through the detailing. Now, there are other requirements and restrictions with wet floodproofing and when you can use it. Some of these apply to historic structures, but many of them you can get exemptions for historic structures. So when you have an historic structure and you're looking at a wet floodproofing option, it's really important to look at your finishes and consider what can be wet and then dried out and what's appropriate and what isn't. Because a lot of code officials will allow you to pursue options for wet floodproofing for historic structures where in new construction they would not. So Caplans, specifically, if we were to allow the building to flood, we would have to make sure that we manage the water entrance and exit in order to keep the pressures stabilized. And then we'd have to detail the storefront finishes and interior partition finishes such that they can get wet and then dry out. Now, dry floodproofing is notoriously difficult with historic structures because there are plenty of pathways for water to enter the structure that are difficult to seal. You think of masonry, you think of joints in masonry with different framing, and you think about windows and doors, and the pressure from the water against your structure causes what would be a leak resistant building construction otherwise to all of a sudden be very porous. So a mass masonry wall, for instance, where water wets the outside, but it's not constantly forced into the masonry, the mass masonry wall will keep most of that water out. It will absorb some water and it will get wet, but it won't constantly pull all the water into the building. When you have a flood, that water is now being forced into your structure, and different materials will allow more of it in. And there has been recent testing by the Park Service to try to look at different historic materials and kind of quantify their performance under different flood considerations. However, it's still a challenge in detailing and coming up with a system that you can justify in the long term. So for Caplans, for wet floodproofing, dry floodproofing, we first have to establish a barrier. Where do we want to keep the water out? And this line is schematically shown. There are pluses and minuses to put it on different sides of walls and slabs. And then you look at the flood demands on it, and you have to detail all the connections in order to resist that. So let's look at one more detail in general to discuss, and that would be at the storefront. A lot of times, in order to resist the hydrostatic pressure at the front of your building, you need a concrete wall or a solidly grouted CMU wall in order to resist the water loads. You also would tend to need temporary gates at your entrances. Now, this sort of construction can be difficult for historic properties if your historic finishes are deemed historic on both sides of your wall. However, if you're in a case like we were at Caplan's, where the finishes are the storefront as seen from the exterior, that gives you some flexibility to play with on the interior and what you can do and what you can see. And again, different floodgates have different benefits, and a lot of times you also have to consider, particularly for tight sites, encroachment into the public space and their sidewalks. So going through this conceptual design procedure, looking at Caplan's, we realized that there are many strategies that are just not appropriate for this structure, and we're left with wet floodproofing and dry floodproofing and some give and take with that. And so that is the kind of conversation that you would need to have with the building owner and all the other officials that are able to make decisions on your project. Now, how does this relate to what actually happened at Ellicott City? Well, this was an event from 2018. As you can see highlighted in this box up here, we have Caplan's on Main Street, and it was just devastated from the flash flooding of the flash floods. The flow rate for the water reached up to 10, 11 feet per second. It was around 7 miles per hour. To give you a sense of force that can create, Caplan's is the first building over the Tiber River, and anything that blocks or impedes the flow of water is now subject to severe damage as a result. So we have the design flood elevation of 133 feet for a 100-year event. 2016 was a slightly worse flood event than 2018. The floodwaters reached 139 feet. So that's 6 feet higher than the base flood elevation. And that's 9 feet above the first floor. You couple that with the momentum of the water, the speed, and the forces are enormous. It's just not possible to resist that with glass curtain walls. And so this leads into an interesting conversation that needs to occur for this project and likely many other communities. And that is, where as an individual building owner, are you able to resist the flood events? And where do you need to draw on other resources? When do you need to consider flood mitigation strategies on a community level? And so where we have individual site level, we're really resisting the demand that meets the building. Where we have a community level, we're trying to limit that demand as it comes to the building. And so at communities, we have retention systems, diversion channels. These are the dams, flood walls, storm surge barriers, and city planning. How do you manage stormwater? And we've been working with Howard County, and this is generally their approach, is we need to reduce the flood hazard to lower Main Street from upstream. And so they're looking at installing upstream retention ponds, and nets and catches to capture debris. And then also diverting water around Main Street so that the funnel points where water backs up and then causes more rapidly moving water in really high flood elevations, we're trying to reduce that flow. And so we're looking at a tunnel to the north of the city, and then enlarged culverts right as the Tiber branch enters the Patapsco River to help deal with this demand. And then finally, we still have a significant amount of flow coming through the Tiber branch, even with all these other interventions. So we need to look at how can we widen the Tiber branch to accommodate that volume of water and not allow it to jump onto Main Street. And so with all this modeling that is done, we said, okay, if all of these interventions are installed, what do we see? This is a flood elevation map of the 2016 event. And you can see on Main Street, the floods get to 8 feet or more above Main Street elevation. But then if you also look at the Tiber and Tiber branch, as it comes down and runs parallel to Main Street, it hits Caplan's department store, and it's actually forced down, and that caused a lot of flooding to punch through onto Main Street. Now, once all these interventions are installed, looking at a 1,000-year flood event, which I forgot to mention is a 0.1% chance of occurring every year, that's how it comes up to a 1,000-year event, we find that the flood elevations decrease at Caplan's from plus 8 feet to right around 1 foot in front of the store. So for a 1,000-year event, the flood at the front of the store more or less gets back to the 100-year event before all the mitigation efforts on the community level were installed. Looking at the channel, we see that the 1,000-year event still has really high water elevations behind Caplan's. And so what does that mean in terms of historic Main Street? And this is the plan for historic Main Street in order to accommodate the high volume of water. They want to have a nice park at the lower Main Street where there's enough room for the water to accumulate and make its way to the Patapsco River. So right now, the river is constricted by a channel or culvert that runs underneath the train tracks and underneath Maryland Avenue. So they're going to increase that flow with additional culverts further downstream, allow for more water to accumulate, and then because the water elevations for a 1,000-year event are still so enormous, we're looking at removing structures that currently extend above the Tiber branch and allowing the water to raise an elevation as needed in this area. And the one structure that still extends it above the Tiber branch, the first floor will be removed. So essentially, we'll gain a whole story height of clearance for the water to flow. So looking at the current construction in that area, what we see are a bunch of existing structures that are all contributing to the historic nature of the city. So Howard County, who is pushing and designing and spearheading this effort, purchased these 10 structures with the intent of giving them more flexibility in order to implement their flood measures, flood mitigation measures for the entire city. Now, part of that plan, after much back and forth in reevaluation of the flood studies and looking at lots of different options, the current plan is settled on demolishing 4 structures out of that 10 and modifying another 4 to 5 structures that extend over the Tiber branch. So coming back to Kaplan's and tying all this together, we look at how does a community intervention impact the structure and impact the intervention that we do at our individual building. And we say, okay, we know that in order to accommodate more water, we have to get rid of this extension and at least get rid of the first floor. And right now we have existing steel that we're keeping at the roof elevation in the back in order to brace this historic wall along the back. So we say, okay, now how do we design it? Well, we start with looking at the 100-year flood elevation and what that looks like. And then, because everybody is really nervous about another 1,000-year storm, because remember, we had 2 of them within 2 years of each other. So within the past 4 years, we've had 2,000-year flood events. Everybody is really jumpy and really nervous. So we want to check our design to see how it's going to fare for a 1,000-year event. So the problem that we have in terms of design community is when you go to submit permits, this 1,000-year event is predicated on implementation of a lot of expensive intervention upstream and hasn't fully been, and it's not completed. It's still in progress, but we're doing renovation work now. And so what we decided to do is we said we have to meet current codes. So we're designing our structure and detailing the finishes in order to resist the 100-year event that's currently on record. We are using a 2-foot freeboard. And then we are also, because we're good engineers, we are increasing the reinforcement and strength of this CMU wall at the back in order to resist the higher water pressure, with the idea that the actual rate that the water will flow through here is going to be greatly reduced as well. You know, there's still the risk of another 1,000-year event occurring before all this can be installed, but you know, we're taking the best precautions that we can, given the information that we have. So this is usually one of the big design questions regarding this specific building and this specific city is how do you think through the design process while we're still working on installing all the mitigation upstream, you know, and eventually I imagine the 100-year flood events or flood elevations are going to be revised based on all of the infrastructure that's being installed. And as a result, designs downtown will likely be only for the future 100-year event after everything's installed. So this is another thing that's going to be interesting to see moving forward. And maybe that 100-year event also changes because we're incorporating data from the recent past and the rain event that's recently occurred. So let's just do quick concluding remarks because I've gone a little bit longer than I had hoped, but flood mitigation of historic structures is not prescriptive. There's a lot of give and take that has to occur. Balancing mitigation and preservation is going to require a lot of communication, and there are plenty of instances where in order to address the real hazards on your structure, you're going to have to look at site or building level solutions as well as community level solutions and do some combination of them in order to meet a resilience that you'd like to see moving forward. And so with that, I will stop talking and go to questions. Thank you.
Great, thank you, Adam. That was wonderful. So we do have a couple of questions. First, so Anne and also Judith, she also asked this question as well. But at what point, well, first of all, Anne said awesome work, and she said thank you, and this is a wonderful presentation, so thank you, Anne, for your kind words. But what point does the cost of mitigation for the owner and taxpayer via federal, state, local loads, etc., outweigh even the historic considerations? Are you familiar with any projects where the decision was, given its high risk location, the building just needs to come down, or was there any kind of historic structure that ended up being abandoned because of its risk? Or,
That's a great question.
Yeah.
That is a great question. And yes, this, this does get into a lot of value-based decision making, and value both in terms of dollar amount and social value for existing structures. So the current plan for Ellicott City is around $150 million in order to install all the infrastructure it needs to reduce the flood hazards. And that price tag is higher than it could have been with some other options. So one of the early options that was evaluated was removal of all 10 historic structures along Main Street that border the Tiber branch, as a way to immediately increase the volume of water that can be accommodated at that end. And there was a lot of pushback to that, and there's a lot of community involvement with hearings, etc., to try to come up with a balanced approach, where now we're looking at removal of 4 structures as opposed to 10. So that's a small example, but still very expensive. I think with 10 structures removed, I don't remember the price tag associated with that. I believe all that information is on Howard County's website, so you can track it down. But so I don't want to quote a number and then be completely wrong about that, but it was substantially lower. There are other communities where they have moved entire villages to a higher elevation, and the thought process there was we would move structures that we want to keep, and we would use federal grants in order to relocate the people in that community. And I'm thinking specifically of, I want to say, a Native American community in Alaska that was relocated. And there are plenty of other locations that they're going to have these conversations. And, there's not a one size fits all, which is why flood mitigation is so interesting about trying to figure out where we want to be, because it's going to be very case specific, and it's going to depend highly on costs. So,
yeah, no, that's a great point. So we had another question from Judith, and for anybody else who might be unfamiliar with the term, what is a 2-foot freeboard? Could you just explain that a little bit more?
Yes, so 2-foot freeboard is an additional factor of safety above the flood elevation. So you have a base flood elevation that's based on modeling, and then the code prescribes other factors of safety associated with that. And they say, okay, most buildings, you'll have a 1-foot freeboard. So the way I think about it is you do all this modeling and you say, okay, for a 100-year event, the elevation is likely to be, let's say use 133, because that's what it was at Ellicott City. If it's 133 and ½ an inch, your entire building is flooded. Mm-hmm. So that's where the freeboard comes in. So just to give that additional factor of safety.
That's great. Thank you. Okay, so Thomas asked, do you have any thoughts about flood mitigation on the historic structures around the National Mall? Do you have any thoughts about that? Yeah.
I do.
I mean, from the map that you showed, it was pretty, yeah, it was pretty intense.
Yeah, and there's more to it as well. So there is currently some flood mitigation measures that have recently been installed on the mall, including a berm along, just north of the reflecting pool that helps keep water elevation from reaching, is that Constitutional Avenue that's to the north, or Independence? I always get them mixed up.
Yeah, no, it's Constitution. Yeah.
Okay, so it keeps water from getting to Constitution. And then they installed a floodgate at 17th, right next to the Washington Monument. And with those measures installed, there's some locations in the mall and then Southwest DC that have reduced flood risk because there's been some intervention. And it's tough. We are looking, so let's talk about the Jefferson Memorial, for example. The gift shop that's there and the bathrooms are currently below grade at the memorial, which means they're obviously below the flood elevation. And so the question then is, how do you detail those spaces? Are they detailed for, dry floodproofing, or do they detail them for wet floodproofing? And when that memorial was constructed in the 1940s, that space was not really meant to be used. There was office space that was at this mezzanine level that was, maybe one story below the statuary chamber, but the very lowest level wasn't really meant to be accessed. And so the question is, water infiltration, how likely will it occur? And then what do you do about it? And that's a question that is going to be tough because, a lot of it is dependent upon available funding as well. I know there's a big project going on with the Smithsonian where they're looking at increasing storage space below Independence Avenue by building another essentially warehouse. And the way that they're going to waterproof that is a box within a box in order to keep the envelope 100% wrapped around it so there's no way water can get in it. And so that helps some measures. Now, what happens with the castle if, let's say, flood elevations, the next time that the flood elevation, the FEMA maps are redrawn, are those elevations increased? Are there more buildings at risk? These are all questions that many communities are struggling with, particularly in the South, along the Gulf of Mexico, where there are a lot of individual homes that are constantly flooded that are having problems, or they're just outside the flood zone and then the maps are redrawn, now they're in it, and so there's a lot of property value destruction that's occurring as a result of flood mapping. And so it's a very complicated discussion. Yeah. The floodgates.
No, that was a really good answer. Let's see. Okay, so Judith followed up about the floodgates on the block of 17th Street. She said they need to be trucked to the site. What do planners think are the chances of this working?
I honestly will have to look into that. I don't know how often, so we've worked with a couple of companies, and there's some floodgate manufacturers that have fabric forms. I don't think they could extend that far across 17th. But there's been a lot of discussion about you have to constantly try out these systems. You have to go through fire drills, essentially, to make sure everything is done correctly and done in an efficient manner. Now, one of the interesting facts about DC is that the Potomac is tidal in nature, And therefore, floods for the Potomac tend to be from tropical storms or hurricanes that you can normally see coming. There are some cases where floods will arise from heavy rain events upstream.
Mhm.
I'm not aware of floods getting to that level that reach 17th Street from rain events. I'd have to check into historic data on that. But my intuition, and again, you're going to have to fact check me on this, is that the planners for that floodgate, if they're going to be trucked in, would be looking at designing this for storms that everybody's watching on their local news and weather events. So they see it coming from the Caribbean.
Right.
I would, if they also have to block rain events from the mountains and heavy snow melt,
Hmm.
that's more of a challenge because that flood can happen pretty quickly. And I sure hope that's not how they're designed, but I don't know.
Yeah. So Bill is wondering, let me read it. Let me read his question really quick. So he said, excellent and informative presentation. We have a historic house on the South Jersey shore. Note the seaside shot you gave, and also in DuPont. Do you work in that area? And if you have any like general predictions of the area as well?
Yes, we do work in that area. So our New York office has done a lot of work after Hurricane Sandy with a bunch of, developers that were looking at protecting their structures. And I can reach out to them to talk about specifics related to the Jersey Shore, and and can get back to you. So feel free to share my information and I'd be happy to help. And then for DuPont, so my impression of DuPont is that a lot of the flooding is going to be local flooding and storm management. D is interesting. And when I first started putting this presentation together, I had a long section on this, but everybody told me it was boring, so I took it out. But DC is interesting in that stormwater management has been really important for how you go through permitting. And you need to retain water on your property given a level of improvement. Historic structures are not exempt from this, so you're probably going to see a lot of structures that are going to have green roofs in order to get the retention to work because of these stormwater management increases. And that's causing other issues that are tangentially related to flooding, but may have a much larger impact on projects in DuPont. And then local flooding, there are ways to model rain events and predict how much water you would see outside of your structure. So that helps. And happy to have further discussions with anybody on this.
Yeah, no, thank you so much, Evan. Okay, so if anybody else, I don't know if anybody else has any other questions, feel free to put that in the chat or the Q&A. Also Facebook Live folks, you're more than welcome to ask questions as well. Those get passed on to us too. Give it a moment, see if anybody else has any final questions.
Yeah,
okay.
A lot happening in the DC area with flooding and stormwater management. Alexandria is another very interesting area with how they're developing their waterfront and management there. So reading into that, they're protecting their historic Alexandria to resist a 6-year flood event. So it's more common and have as high of an elevation. However, it's a historic downtown. And so the question is, if you're protecting it from a 6-year event, and we saw that graph where we have a 100-year event, at a certain point, your historic city center is going to see it. And so that's a long-term question. I think as a community, we need to be discussing this more.
Yeah, no, I totally agree. Yeah. We have a couple folks asking if this will be made available following the event. Yes, it will. You can find it on our Facebook. Adam, I don't know if SGH also has a recording of it, but we will of course send this to you if you would like.
Yeah, that's a good point. We do have a recording with Ricardo and myself from April. If you reach out to me, I can get that to you. And then our marketing group also can get you that. And we also, it's a little plug, we have been putting together webinars on a weekly basis, covering a wide range of engineering topics, including, glass breakage, fire, and earthquake reconstruction. So there's a lot of good information that's on our website, and you can easily get added to that list so that you can be up to date with those. They're usually about an hour long and very technical, but they're for the general population as well.
Yeah, and kind of going off of that, I have some links to different resources that might be helpful to folks, including the SGH website, where all of these great webinars can be found. Also, I have a link here to the APT DC 2020 Symposium. Adam, I know you mentioned that you were going to present at that. Did you have any other notes to tell folks about it?
Yeah, I will be there, and then Jen Wellick from NPS, who was instrumental in their latest flood mitigation guidelines for historic structures, is going to be there to talk about those guidelines. The presentations will be short, so I think the idea is that we're hoping to get good discussion afterwards. And then the symposium, if you go to that website, there are a lot of other topics with risk for historic structures. So this is going to be a really interesting event, with flood just being a small part of it.
Yeah, that's great. I definitely plan to check it out. I hope you all do as well. Yeah, I also have something here from the National Park Service, their climate change program. The 2020 DC Preservation Plan has some notes about kind of environmental plans and preservation in the city. There's also some good maps from Climate Central. So please make sure you guys all check that out. And with that, I will close this out as we are running out of time. But first, I want to thank you all so much for attending this program. We're thankful that you took the time to learn more about this important topic, and we give a big special thank you to our wonderful presenter, Adam, for sharing your expertise with us. And again, if you have any additional questions that maybe you didn't think of during the program or we didn't get to, I will make a note of any other questions that folks might have as they're heading out, but also, you can email us at info@dcpreservation.org, and we will pass those along to Adam.
I just shared my web email. I hope that's okay.
Oh yeah, no, that's totally fine. Yeah, no, that's great. So yeah, you can find Adam's email address also in the chat. And you can learn more about the DC Preservation League and our work, and stay up to date on upcoming events on our own website at www.dcpreservation.org. And again, we have the website for SGH in the chat as well. And please make sure you check that out as well to learn more about them and the work that you guys are doing, Adam, and the webinars and events that they're also offering. You guys are, SGH is also on LinkedIn, and you can follow them there as well to stay up to date with what they're doing. So again, we hope you all enjoy your day, and thank you so much again for joining us today, and thank you again, Adam. And like I mentioned before, there will be a recording of this presentation offered following the program. So with that, thank you all so much.
Thanks again, everyone.
Yeah.
Have a good day.